Section 4 involves point slope form. So we learned in the last section that we have this thing called slope-intercept form, which is y equals mx plus b, which you have to have memorized. Point slope form is another form for linear equations. And it's a really nice one to use once you learn how to use it. So point slope form is sitting right here. Y minus y1 equals m times x minus x1. That's the form that you have, that you need to memorize. Basically, the more you work with it, the faster it'll be to memorize it. So I want to talk about the various parts on here. What's m? Slope. We know that one. What are y and x? What were they in slope-intercept form? Y and x were starts with a V. Variables. So this guy and this guy are your variables. So the only thing that's new on this one is this x1, y1. What is x1, y1?
Point.
It's a point. So they'll give you an ordered pair, x1 comma y1. And then you just plug x1 in right there. You plug y1 in right there. And you just write y minus that y coordinate equals your slope times x minus your x coordinate. That's point slope form. So you're going to use point slope form whenever you're given a point, x1 comma y1, and the slope m. Or you can use it if you're trying to find the equation for a line, which we'll get to before the end of this section. So first of all, we want to practice writing the equation just given a slope and a point. So I'm giving you, write the equation in point slope form for the line that passes through 3 comma negative 2 with a slope of 1/4, and then graph the equation. So our point slope form is y minus y1 equals m times x minus x1. We just plug those numbers in and we're done. So it's going to be my ordered pair here. This would be my x1 and my y1. So I write y minus, and then y1 is negative 2. So I write negative 2 equals m, which is 1/4, times x minus, and then x1, which is 3. Now I have this minus negative 2 here, so what am I going to do there? So that's a plus 2. So y plus 2 equals 1/4 x minus 3. That is the equation in point slope form. They ask for the equation in point slope form. That's it. Later on in this section, we'll be asking you to put it back in slope-intercept form. But for right now, that's point slope form, so that's your answer. Then it says graph the equation, so we're going to graph it. To graph an equation that's in point slope form, you take your point, which was 3, negative 2, and you plot that. In slope-intercept form, we graph the y-intercept and then we plot the slope. In point slope form, we have to plot the point that we're given. So 3, negative 2 is right there. And then we use the slope. So it's a slope of 1/4, so that's a rise of 1 and a run of 4. 1, 2, 3, 4. I'm out of room that way, so I'll go the other way. Down 1, left 4. Down 1, left 4. And I'm out of room that way. Then I can draw on my line. Next it says, now graph the equation y plus 6 equals negative 5 times x minus 4. So that is in point slope form as well. We need to figure out on this one what the ordered pair is that they gave us, since they didn't outright tell us what the ordered pair was. We know the slope already. What is the slope? What is it? On this equation right here, what is the slope? It's negative 5. It's sitting right here. So now we've got to figure out what the ordered pair was in point slope form. What is it? 4 comma negative 6. Why is it 4 negative 6? Yeah, because point slope form says y minus y1. But I don't see a minus, I see a plus right here. Which means what we must have had was y minus negative 6 in order to turn that into a plus. So therefore my ordered pair here must be 4 comma negative 6. That's the trickiest part about reading point slope form. You have to remember that there's supposed to be a minus sign there and there. So if you don't see one, the number here is actually negative to make the minus minus turn positive. Yeah, lots of negative signs, so be careful. Now that we know what the ordered pair is, we can graph it. So we go to positive 4, negative 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 down, and there's my ordered pair. And then we use the slope of negative 5, which is the same as negative 5 over 1. Remember, I recommend you do that until you understand that a negative 5 slope is a rise of negative 5 and a run of how much? 1. So with my negative 5 over 1, I'm going to go down 5 from here, but I can't because I'm out of room. So instead, I'll reverse it. Instead of going down 5, right 1, I'm going up 5, left 1, up 5, left 1, and then I'm out of room again. So I'm only getting 3 dots on this one, but that's fine. We can draw on that line now. For you guys, since you're probably writing in all one color, I would make sure that I come up with some way to label that that one goes to that bottom equation, and the first one we drew goes to that top equation. Okay, just a few examples here on writing equations in point slope form. I'm giving you the point and the slope on all 4 of them. So for this first one, we're going to write y minus what? 5 equals your slope, which is 3, times x minus, so x minus negative 2, which turns into plus. We do a change on that. So I'm going to simplify it down to y minus 5 equals 3 times x plus 2, and that's my answer. If you see that it needs to turn into a plus, then go for it. Write it down as a plus, and then you really only have to write down one step. So let's talk about the second one here. What am I going to write? A little louder. Y. So minus negative 7 turns into y plus 7 equals negative 1 times x minus 4. Because I simplified it as I was going along, I didn't have to write down another step. So that's the answer right there. Go ahead and try the other 2. What should we write for this third one? Looks good. And the last one. Perfect. Now, what is y minus 0? It's just y. So I guess I could simplify that to y equals 1 times x minus 1 on that one. Yeah, that should look kind of familiar to you. Because in the next section, after we get done with these 4 homework problems right here, we're going to wind up distributing that slope in, and then we'll be in slope-intercept form. But for now, you can do 8 through 11 all. Should take almost no time. Most of the time, point slope form is pretty meaningless. That doesn't mean it's not useful, though. Point slope form is very useful. You're going to have to rewrite the equation most of the time from point slope form into slope intercept form, because that form has a lot more meaning to us than point slope form does. Especially if you want to graph. Graphing in point slope form is too easy to make mistakes. But it's easy to switch from point slope form to slope intercept form. And once you've done that, it's easy to graph slope intercept form. So that's why we're going to practice here. I have three equations in point slope form, and it's very straightforward to go from point slope form to slope intercept form. The steps are always the same. The first thing you're going to do is distribute. And then the last thing you're going to do is move this term to the other side. That's it. It's two moves. The math might involve fractions. Deal with it. It's not a big deal. It's two moves to go from point slope form to slope intercept form. So let's do it. First thing we're going to do is distribute. I'll leave the y minus 1 alone for now. I distribute negative 2/3 in, and I get negative 2/3 x plus 10/3. It's positive because of the negative times negative is positive. And then 2 times 5 is 10/3. The only other thing I have to do now is get y by itself. So I add 1 to both sides to get rid of that negative 1. Plus 1 there, plus 1 there. Draw my line. On the left side, I'm left with y equals. I didn't do anything to my x term, so I still have the negative 2/3 x. And now I just got to figure out what 10/3 plus 1 is. No, it's not 11/3. It's 13. 1 turns into 3/3. You have to have a common denominator. And then 10 plus 3 is 13. So positive 13/3. That is now slope intercept form. 4 1/3. Yeah. Okay, it's two moves. Distribute the slope and then get y by itself. So let's do the middle one. What should I do? Okay, distribute. So I have y plus 3 equals 3/2 x. 3/2 times 1? 3/2 times 1 is 3/2. Something times 1 is what you started with. Okay, one more move. What do we do? Subtract 3 from both sides. It's not always going to be nice, easy numbers. So you got to learn to work with them. On the left side, we're left with what? Y equals 3/2 x. And now I got to figure out what 3/2 minus 3 is. It's negative 3/2. So common denominator, right? The common denominator is going to be halves, which turns this minus 3 into minus 6/2. So I have 3/2 minus 6/2, which gives me negative 3/2. So that's my answer. And of course, you could enter it into your calculator if you didn't feel like thinking. But if you don't have a calculator, you need to know how to do it by hand or in your head. Let's go ahead and do that last one. What do we do first? Distribute, so we get y plus 6 equals plus 12. Good. And then subtract 6 from both sides, and we get plus 6. Way easier to graph if you were asked to graph that than it would have been in this form here, because then you got to think about, okay, is it positive or negative? What's my ordered pair? Then you got to graph that and then use the slope. This makes it very easy. 12 through 15 on your homework assignment, you're capable of doing those now. A little bit of geometry on this page. I'm giving you a graph. The shape of that thing looks like it might be, what? Square. In geometry, you guys might come up with, you might be given a problem like this and come up with equations just like we're about to do here. So we're going to use point slope form to generate the equations for all of these segments here as if they were lines. So we'll imagine that these are actually lines forming this square right here, even though all I see is segments. That's what this is saying. shows square RSTU. Write the equation for the following lines containing the given segment in point slope form. So I want the actual equation for the line. This notation right here means what? Yeah, segment. That's a segment because of that bar on top. If it was a line, it would have arrows on top of it. This is a segment RS. So RS is this guy right here. So I'm talking right here in part A about the line that would form that segment. It's going to be helpful if I know the ordered pairs for this point R. What is that ordered pair right there? 1, 5. X coordinate comes first. And what is the ordered pair for S? 1, 2, 3, 4, up to 8. So 4, 8. Now to write something in point slope form, I'm going to have to figure out what the slope is, and then I'm going to have to figure out one of the ordered pairs that's on that line. So what's the slope of that segment? 1? How do you know it's 1? So you did 8 minus 5 divided by 4 minus 1. You certainly can. You get 3 over 3, which reduces down to 1. Or because we're given a graph and a grid, we can go up 1, right 1, up 1, right 1, up 1, right 1. The slope here is 1 over 1, which is 1. Okay? So on this one, RS, m equals 1. And then I just need an ordered pair. Well, I have 2 of them. Which one do you want to use? Whichever one you want. It doesn't matter. So a line in point slope form for RS would be y minus, I'll use R, so 1 comma 5. So it'll be y minus what? 5 equals 1 times x minus 1. That's your equation. Is that the only equation I could have come up with? No, because I could have used the other ordered pair. And then I'd have y minus 8 equals 1 times x minus 4. Different looking equation, but it's for the same exact line. I'll write that one down as well. Y minus 8 equals 1 times x minus 4. Okay, for ST, we want to do the same thing. So now I'm talking about this segment right here. So that was that one. And I'm going to change colors and go with red for that one. So I'm talking about ST. I already know that ordered pair for S, 4 comma 8. The ordered pair for T would be what? 7, 5. It's not that I need to use it, but it could be helpful. So let's go ahead and write an equation now for ST. What do we need? Slope is what? What? That line is going down from left to right. It's negative 1. Yes, I heard you. Okay, so I need an equation then. Which ordered pair do you want to use? Okay, so I'm going to write y minus 5 equals negative 1 times x minus 7. I could have used the other ordered pair on S because it's on the same segment, but I didn't. I used this one instead. No big deal. It gives me an equation. Go ahead and do the other two, one for TU and one for RU. Do I need to find the ordered pair for U on this one? I actually don't need to, because all I need is 1, and I already have 1 for this segment right here. What about when I try to find this one? Do I need to find U for that one? I don't need to, because I already have that ordered pair right there. But let's do it anyway. What is the ordered pair for U? So it's x coordinate first, 4 comma 2. All right, so for TU, what is the slope? for TU, it's positive. Segment goes up from left to right, so m equals 1. And an equation I could write would be y, what? Minus 2 equals x minus 4. Okay, so you did use u on that one. Did anybody use t? Nobody? One person? Okay, so your equation for t would be y minus what? 5 equals 1 times x minus 7. So that's a perfectly valid equation as well. And how about for RU? Yeah, the slope is negative 1 this time. Let me make that look like a negative 1. There we go. So what's my equation? Notice that this time we used the exact same ordered pair as we used for the other one, but because we have that different slope, it's a different equation. Did anybody use the other ordered pair? Okay, what'd you get? Y minus 5 equals negative 1 times x minus 1. Yeah, so that equation works as well, okay? And that's kind of the bummer about point slope form. There's no one equation that works, or that is only true for point slope form, because if I have a bunch of ordered pairs, as long as I know the slope, I can pick any one of those ordered pairs and plug it in and I'll have a correct equation. So that's why most of the time you're going to see these directions. Write each equation in slope-intercept form. For every equation that we have on here, we're going to now put it in slope-intercept form. 1 for practice, and 2 so that we can see that they are exactly the same equation. So let's take a look at this first one, this top one right here. I wrote both of them down. Let's put it in slope-intercept form. So to do that, I got to distribute the 1. Okay, so I'll have y minus 5 equals 1x minus 1. And now I add 5 to both sides. And I get y equals 1x plus 4, or just x plus 4. If I put the other one in slope-intercept form now, I got to distribute the 1, and I have y minus 8 equals 1x minus 4. And then this time I'm going to add 8 to both sides, and I get y equals 1x plus 4, or just x plus 4. Notice that we got exactly the same slope-intercept form. And we should get exactly the same slope-intercept form, no matter what. Because they're going to have the same y-intercept if they're the same line. And they're going to have the same slope if they're the same line. But in point slope form, as long as I have any ordered pair on that line, I can write a different looking equation, even though it's exactly the same. So what should I do for part B if I'm putting it in slope-intercept form? Distribute, and when I distribute that negative 1 in, I get y minus 5, negative x plus 7 this time, and then plus 5, plus 5, negative x plus 12. And if we had the other one written down, we could do the same thing. We'd get the exact same answer. Notice that if I extended for this first one right here, the y equals x plus 4, if I extend this segment down, it does seem like it crosses the y-axis at 4. If I extend this segment up, since it's 8, that'd be 9 and then 10 and then 11 and then 12. It does cross the y-axis at 12. For this one's going to cross the y-axis, looks like at about 6. This one down here is going to cross the y-axis somewhere negative. So let's go ahead and make the slope-intercept form for these two lines right here using the equations that you came up with. And we'll see if we wind up with exactly the same slope-intercept form equation. So for the third one, I'll just go ahead and go at like my speed so that you can see how fast you can get at this by the time you have some practice. I'm distributing the 1 in, and I wind up with y minus 2 equals x minus 4. Add 2 to both sides, and I get y equals x minus 2. And on the last one, I distribute the negative 1 in, and I get y minus 2 equals negative 1x plus 4. Add 2 to both sides, and I get y equals negative x plus 6. Both of those were kind of what we expected. Did you get the same thing, even if you used a different ordered pair? Seeing some head nods, yes. You should. So that's why most of the time I'm going to ask you to put things in slope-intercept form. I'll ask you to write an equation for a line in point-slope form, but then put it in slope-intercept form, because no matter what ordered pair you use, by the time you put it in slope-intercept form, everybody will have the exact same answer. Makes it easier to check. Plus, slope-intercept form has more meaning to you. So sometimes, occasionally, once in a while, somebody will say, why does point-slope form work? And here is the answer for you. If I were to want to get rid of this denominator right here, what would I do? Anytime I want to get rid of a denominator, I multiply both sides times the denominator, right? By the way, what is this right here that we're looking at? When do we use that? When I give you two ordered pairs and you're trying to find the slope. This is the slope equation that you're looking at. And we know that the slope equation works. We've been working with it this entire chapter. So what I'm going to do is use the slope equation to show you why point-slope form actually works. By getting rid of the denominator here, all I need to do is multiply both sides by the denominator, x2 minus x1. x2 minus x1. It's sort of like if I have 1x over 5 equals 12, and I wanted to get rid of the denominator there, I multiply both sides by the denominator. Okay, same thing. The denominator here is x2 minus x1, so I multiply both sides by that. That gets rid of the denominator on the left, or sorry, on the right, so I'm left with y2 minus y1 equals m times x2 minus x1. Sound familiar? If I'm given an ordered pair, x1 and y1, then this is the ordered pair that I'm given right here. If I use any other ordered pair, because that's any other ordered pair, that stays a variable, which means that my x2 and y2 become my variables. So now, and I can write that m out front. So I have the m times x minus x1 equals y minus y1, which is exactly the same as y minus y1 equals m times x minus x1, which is point-slope form. Okay? So that is why point-slope form works. It actually is the slope equation, just in a different format. You're just looking at the slope equation in a slightly different way. The table shows the altitude of a hot air balloon during its linear descent. So if I was to graph this, because they tell me it's a linear descent, should my graph look like this? Like this? What should it look like? It should look like a line, because it says a linear descent. Write an equation in slope-intercept form to model the balloon's altitude at any time. What do the slope and y-intercept represent? So the first thing we're going to do is write the equation in slope-intercept form. In order to do that, I'm going to use the data here. Notice, how much do we change from here to here? 20. And from here to here? 40. And from here to here? 20. And how much are we changing from here to here? It's not 50. It's negative 50. Remember, we're descending, so we need to be decreasing our altitude each time. How much do I change from here to here? 590 to 490. Negative 100. And then how much do I change from here to here? It's negative 50 again. So is that linear data right there? Yes, because I'm changing by the same amount each time, even though the interval of time here goes from 10 to 30 and then from 30 to 70. So 20 seconds and then 40 seconds and then back to 20 seconds on here. So twice as long of a window. But look over here. We're descending negative 50 here. And then we go twice as far here, and then back to what we started off with here. So our data is actually linear. If I were to graph that, we'd have that data point, and then we'd have that data point, and then we'd skip a data point to there, and then we'd skip another data point. So we've kind of missed one here. It's not a big deal. We're still forming a line. I need to calculate the slope. The slope is the change in y divided by the change in x. And because we said this is linear, I can take any change in y and divide it by any change in x. So m equals the negative 50 divided by the 20, which I reduced down to negative 5 halves. Okay, rather than bothering with trying to figure out what the y-intercept is by writing my equation right now in slope-intercept form, I'm going to use point-slope form to start. So I'm going to write y minus. All I need is a y1. I can use this first-ordered pair right here that I'm given. 640 for that y1. So y minus 640 equals my slope, negative 5 halves, times x minus the x-coordinate there, which was 10. Just pulled one random ordered pair. You can pick any ordered pair you want off of that set of data. I picked the top one. They say in slope-intercept form, though, this is the equation for this hot air balloon, but they want it in slope-intercept form. So what do? Distribute. So I have y minus 640 equals negative 5 halves x plus 50 over 2. Well, what is 50 over 2? 25. And one more move, and I'm in slope-intercept form. Add the 640 to both sides. And I get y equals negative 5 halves x plus, we do that one in our heads? 665. Okay, so it's in slope-intercept form. That's my answer. Then it says, what do the slope and y-intercept represent? Let's talk about the y-intercept first. What is that? Y represents what? The altitude. So when we are at our y-intercept, the x-coordinate is 0. What does x represent? Time. So when time is 0, the altitude is 665 feet. So what does the y-intercept represent in words? So how high the balloon was when? How high the balloon was when? What does 0 time mean? When it started to descend, yeah. So in words, the y-intercept represents how high the balloon was when it started to descend. Okay? What does the slope represent? The rate of change that the balloon was descending. Okay, so let's put that in like actual units here. It was y over x, y divided by x. So the change in altitude divided by the change in time. Okay? So this negative 5 divided by 2 represents 5 meters. It falls 5 meters per every 2 seconds. That's what the slope represents.